Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It is question 1 from the summative package. And this question actually has 5 points, so A, B, C, D, and E, all of them to do with this triangle ABC. And the first question just says to draw the triangle, so I did that already for you in advance just to make it nice and neat and because I know that you can all draw triangles. So I'll just put XY here, so I said I did it. So that's part A. Determine the coordinates of the midpoints of AB and AC. Label these midpoints D and E. So AB is this line segment here, and somewhere around here is a midpoint, and we want to find it. And AC is this line here, and again, somewhere around here is a midpoint, and we need to find it. So let's use the midpoint formula. So let me just remind you that the midpoint between 2 points can be found using this formula. So as I'm writing the formula, let me just say a couple things. First of all, when you write any fraction, don't do it like this. This is not a valid fraction line. It's a mark on the page. Make sure that your fraction line um, extends past the longest part of your numerator or denominator. Otherwise, you're just kind of being silly by saving yourself no time. Also make sure that because midpoint is a point, that you have these brackets and the comma because you're looking for the coordinates of the point. So you're looking for the x coordinate and the y coordinate, and every valid point needs to be in the brackets with a comma. Just another thing, what is the formula doing? Basically what the formula does is it finds the average of the x values and the average of the y values, and when you put those together as a point, you get the midpoint. So let's do the math. So I need to find the midpoint of AB. So midpoint of AB, which is actually labeled as D, is, and here's something I like to do on this piece of equipment, which is to actually highlight the coordinates I want to use for the moment, because otherwise it's really easy for my eyes to wander to the wrong coordinates, and I've done that an awful lot, as most of my students can tell you in class. It's very easy for anybody to just kind of find the wrong coordinate with your eyes and write it down. So anyway, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So doing the math on this, point E is 6 divided by 2. That's 3 for the x-coordinate and a half for the y-coordinate. So on my diagram, I need to put a point at 3 a half, which is right there, which looks definitely like the midpoint of AB. Good, so now we're going to do the same thing, but now we're going to find the midpoint of AC and label it E. So let me erase my highlight because that would be definitely distracting. And in fact, why don't I just go ahead and erase this, since if you want to see it again, you can just rewind and press pause. I'm sorry, I'm old. You can just pull the video back and press pause. Okay, so let's find point E. Point E is the midpoint of AC. And again, let me highlight the coordinates that I want to use because I don't want to mess this up. There we go. Those are the coordinates I'm about to use. Okay, so I need x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And when I do the math on this, I'm going to get, negative 1 plus 4 is 3, so 3 over 2, and then negative 2 plus 7. Okay, so 9 over 2. So point E, the midpoint of AC, is 1.5 on the x-axis, and then go up 3.5, and that looks good to me. I would say I found the midpoints. Good. So part B is done. Determine the coordinates of the midpoints, and so on. Okay, so next slide, next part of the question. So you'll notice that what I did here is I, in advance, before you got here, already made this graph nice, and I even put D and E on it. And here are the coordinates from the other page in case we need them. It says, show that DE is half the length of BC. So DE is the line segment that connects midpoints to midpoint. So there's D to E. So now I can see that here's line DE and here's line BC. And again, I'm supposed to show that it's half the length, so I need to find the length of a line segment. And the length of a line segment is the same thing as the distance between 2 points, and we have a formula for that. So I'm going to add line DE just to visualize. Oops, neither of those worked out very well. So here's line DE. Not happy with that one either. There we go. That's better. So there's line DE, and since we found the coordinates of D and E, let's make sure that we have those available to us. There they are. And now we want to find length. So here's the formula that you should know for the length of a line segment, or the distance between 2 points. It's a big square root and x2 minus x1 squared plus y2 minus y1 squared. So just a couple of quick things to say about this formula. First of all, make sure that when you're writing square root signs, you're not being lazy about it. To me, one of the most terrible things I see in terms of communication is a student who does this. Draws a square root sign that sort of just stops randomly and for no reason. Nope, the square root sign needs to clearly go over exactly what you want to square root, and if you have any doubt, you put the little kind of closing thing at the end, but boy, I haven't done that in a long time. Okay, what else do we need to know about the distance formula? Effectively, the distance formula is the Pythagorean theorem. Basically, the Pythagorean theorem is a squared plus b squared equals c squared, but we write it as c equals the square root of a squared plus b squared. So that's the distance formula is a version of the Pythagorean theorem, because if here's a point and here's a point, here's the x coordinate, here's the what I would call delta x, or the difference in the x coordinates, and here is delta y, or the difference in the y coordinates. And if I now draw the line segment between those 2 points, then I've created a right angled triangle with c squared and a squared and b squared and the Pythagorean theorem and so on. So that's not really something you need to know. You need to know this formula, but I'm hoping that you know, remember where it came from in case you ever forget it. I know that I like to know where it came from because it reminds me, it helps me remember that this is a plus sign because it's a squared plus b squared, and that these are subtraction signs because it's the distance between the x and the x. So it helps me. Anyway, that's not why you came here today. We're trying to find the length of DE and compare it to the length of BC. So let's go ahead and use the formula and find the length of DE. So x2 minus x1. Oh, boy, that was almost a disaster. Let me fix this. x2 minus x1 plus y2 minus y1. So a bit of some fraction math going on. I need a common denominator in the first bracket, so 6 over 2 is my common denominator. And here I already have a common denominator, so the denominator's 2 and the numerators say 7 subtract 1. So there we go. So in the first bracket, I have negative 3 squared, negative 3 over 2 squared. And in the second bracket, I have 6 over 2 squared. And you'll notice I didn't reduce that to 3. 6 divided by 2 is 3. But I'm sort of, looking holistically at what I have to do. Here I have divided by 2, and I'm about to square it. Here I have oh, sorry, I didn't notice that happened. Oh, giant eraser. Again, here I have divide by 2, and I'm about to square. Here I have divide by 2 and I'm about to square. So I'm actually going to leave them both with the same denominator so that I can end up with the same denominator after I square as well. So negative 3 squared is 9 and 2 squared is 4. 6 squared is 36 and 2 squared is 4. So in that bracket I have root 40 over 4. Now, square root of 40 is not really a nice number, so I'm going to leave square root of 40. But the square root of 4, which is what's in the denominator, that's kind of nice. The square root of 4 is just 2. So I'm going to write this as root 40 over 2. Now, in grade 10, you haven't yet learned how to simplify radicals, so I'm not going to go through that process. It's not something I want you to worry about right now. So if you want, go ahead and get the decimal, the square root of 40, and then divide it by 2, so I get 3.16. So the length of DE is the square root of 40 divided by 2, or about 3.16. So what I'm going to do is I'm actually going to record that again right here. And it's the square root of 40 divided by 2, which is about 3.16. So, and the reason why I'm recording it here is because now that I've done this, the length of DE, I'm going to erase this math. And again, if you want to see it, just pull the video back and press pause. Because that's what technology lets us do. So erase, erase, erase. Yeah, I could use a bigger eraser, but you know, that's all right too. Okay, so now let's find the length of BC, and it'll go a little faster because there's no fractions involved. So the length of BC, here we go. Ooh, that's it. BC, there we go. So x2 minus x1 plus y2 minus y1. So I have negative 3 squared plus 6 squared. So I have 9 plus 36. So it's the square root of 40. Now, hopefully you're already thinking, hooray. And in case you're not yet thinking away, don't forget to look over here and see what happened there. And just, you know, in case you really don't like this whole radical thing, I will let my calculator give me an approximate value for square root 40, which is 6.32. So 6.32. So if you compare the length of BC to the length of DE, you can definitely see if you look at the radical sign, and let me highlight this one, that for BC I have root 40, and for DE I have root 40 divided by 2, which is half of root 40. Now you can also compare the decimals, of course, that 6.32 divided by 2 is 3.16. So therefore, BE is half the length of BC. Okay, next question. Show that DE is parallel to BC. Okay, so again, we're talking about the line that connects D and E, and we're asking if it's parallel. So parallel means we need to look at the slopes of those lines. So let's find the slope of both those lines. So here's the slope formula. So slope is a ratio or a fraction that compares the rise over the run of a line. So looking at, well, let's look at the slope, so a small case m of dE. So here's the points D and E. So y2 minus y1 over, let me just fix my brackets here, over x2 minus x1. Okay. So again, don't worry too much that there's fractions inside of fractions. We'll deal with it. And the way we're going to deal with it is we deal entirely with the numerator, and we do all the math we can in the numerator until it's hopefully just a single fraction. And we're going to separately do everything we can in the denominator until we get just a single fraction if we can. And then we'll deal with this divided by sign right in the middle. But let's worry about numerator, denominator, and then we'll worry about how do you divide fractions. Boy, I like highlighting things. Okay, so let's get rid of those highlights because they're sort of distracting. So in the numerator, I have 7 over 2 minus 1 over 2, and that's already a common denominator. So that's just 6 over 2 there. In the denominator, I need a common denominator in the denominator. I just wanted to say that word again. So this would be 6 over 2. So what I have is 6 over 2 over negative 3 over 2. Now I have just a single fraction for this numerator and a single fraction for the denominator. And the question is, how do I deal with these fractions? Well, there are a number of shortcuts you could take, but I'm not going to take the shortcut. I'm going to show you kind of the full, here's what you can always do approach to this sort of thing. This line, this fraction line, oh, I didn't really want purple, whatever, means divided by. And, oops, sometimes what helps is actually rewriting this as a divided by statement. So instead of saying 6 over 2 over negative 3 over 2, I'm actually going to write it as a divided by statement. And the reason why is usually as soon as I write it like this, most students recognize immediately what the next step would be. Because we have a rule in math that says if you divide by a fraction, the math you need to do is to multiply by the reciprocal. So I had negative 3 over 2. The reciprocal is negative 2 over 3, and now it's a multiply question. So I get negative 12 over 6, and that reduces to negative 2. So the slope of DE is negative 2. So I'll just say the slope of DE is negative 2. And again, if you want to go back over that stuff, feel free to pull the video back. I just want to now use this space to calculate the slope of BC. I'm going to take a lot less time because I don't have any fractions to worry about other than the main slope fraction, rise over run. So now I'm going to look at BC. So here's BC. So y2 minus y1 over x2 minus x1. So I get 6 over negative 3, and that reduces to negative 2. And that's a good thing because I wanted to show that they were parallel. And because they have the same slope, they are parallel. Okay, almost done the question. Question E says, show that the triangle formed by joining the midpoints of the sides is similar to the whole triangle. So in other words, when we connected point D to E, we created a little triangle here called triangle, well, let's call it triangle ADE. So we created this little blue triangle with this midpoint line. There's also the main triangle that we were working with the whole time, which I'm now shading in yellow, so it covers over it. There's also triangle ABC. And we need to show that they're similar. So how do we know if triangles are similar? Oh no. Technology. If two angles of a triangle have measures equal to the measures of two angles of another triangle, then the triangles are similar. So that's pretty formal. Let's make sure that we understand what that means. So if I have a triangle over here and another triangle over here, and two of the angles in this triangle are equal to the angles in this triangle, then these triangles are what we call similar. Okay, and we only need two triangles to be the same, because if these two triangles are if these two angles are the same, we know that the third angle must be the same, because we know that all the angles in a triangle add to 180. So if we go back to the slide we were on with these two triangles, let me remove some of my shading so we can see the triangles. Oh, that's kind of neat. Somebody want that? Do, 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 do. Oh, cool. Anyway, so here's what I know about triangles ADE and ABC. Well, first of all, they both share angle A. So let me clear some space here. try to get rid of a few things. So I know that angle BAE is the same as angle BAC. And that's because it's the same angle. Kind of looks like I said game. Same angle. So in other words, the angle that I trace from D to A to E is the same as the angle I trace from B to A to C. And that's because it's the same angle. They're both formed of vertex A and the sides that make up vertex A. So I know there's already one angle that's the same. Uh-oh. Now, because we know from a previous question that DE is parallel to BC, I know that this line segment must meet side AB at the same angle as this line segment. In other words, or more familiarly, according to the parallel line theorem F pattern, so again, let me just show you what that looks like. Here's an F, and if these are parallel lines, the F pattern tells us that these angles here, which I affectionately call the armpit angles, must be equal to each other, and that's because these parallel lines would intersect this transverse line at the same angle, otherwise they're not parallel. So I know that this angle must be the same as this angle, and that's because of parallel lines. So I can say that angle, so I would say EDA, EDA is the same as triangle. So I went EDA, so I have to go CBA. Angle CBA. And my justification is that it's a parallel line theorem angle, and it is the F pattern. Of course, this notation, just use whatever standard your teacher prefers. So there's my two angles that are the same, and therefore I have angle similarity. And that's what I needed to show. Okay, well, that was a long video, but there were a lot of steps to that question, and I like to talk and explain things. Well, thanks for watching, and if I'm smart, I'll figure out how to set up my YouTube so that it automatically plays the next episode. Anyway, have fun with math, guys.